Alright guys, welcome to lesson 3.2. In this lesson we're going to be talking about transformations. So what is a transformation exactly? Well, a transformation is something that you do to a function that will either change its position on a graph or even change its shape a little bit. So there are 4 different transformations we're going to be looking at in today's lesson. Translations, reflections, stretches, and compressions. Oops, not too far there. You should be able, so there's going to be 2 things we're going to do with those today. Okay, so one thing is if I give you a function with some transformations written on it, you should be able to tell me what those transformations are. Okay, you should also be able to write some new equations that would reflect what those transformations would be. Okay, so you're going to learn how to read and write transformation notation functions today. All right, so look, what is a transformation? Kind of already addressed that, but it means that a function is being changed by some sort of mathematical operation. It affects the way that the function equation looks, and it also affects the way the graph appears if you were to graph it. And there's 4 types. There's the translation. Translations are basically something that results in sliding a graph. So like if you had a parabola centered in the middle of your graph, a translation would slide it somewhere, like up, down, left, or right. It doesn't change the shape, it just slides it somewhere. Reflections flip a graph either sideways or upside down, horizontally, vertically. So reflections just flip it around. Compressions squish the graph. They make it look either, you could either squish it vertically so it looks shorter, or you could squish it horizontally so it looks skinnier, but that's a compression. Stretches may either, if you stretch it vertically, it makes it look longer, and if you stretch it horizontally, it makes it look wider. Okay, so there's different kinds of stretches and compressions. Now, since functions have both x values and y values, transformations can apply to the x's or the y's. Transformations that apply to the y values result in vertical changes, right? Because we know that the y value, since it's the output variable, that one goes on the vertical axis, the up and down axis. And so when you change the y value, it's going to result in a vertical transformation. So it will either translate it up or down, reflect it up or down, compress it vertically, or stretch it vertically. But if you were to apply a transformation to the x values, it results in a horizontal change to your graph, a horizontal transformation. So if you were to do something to the x value, that would slide it to the left or right, or it would flip it sideways for reflection, or it would compress or stretch it horizontally. So there's vertical and horizontals, and we're going to start off with the verticals. So right here on this graph, I've given you a function f of x, and it looks like a v, as you can see here. Now, vertical translations. Here's how these things work. If I were to add a number to the function, then what that's going to do is it's going to shift the graph upwards. Okay. Now, why does that happen? Well, the f of x represents the y value, doesn't it? So if you take your y value and you add something to it, then the y value gets bigger. So for instance, for this point right here, what's the y value for that point? It's 4, right? So if I were to add 2 to 4, what do I get? 6. So I added 2 to the 4 and I got 6. We add 2 to all of these points, then they're all going to go up 2. So like for instance, right here, this y value is 3. 3 plus 2 is 5. This one's 2. 2 plus 2 is 4. 1 plus 2 is 3. And so the result is every point gets shifted up 2 spaces on this graph because I added 2 to the y value. And another way to write the y value is just f of x. So if you add a number to your function, then it shifts the graph up. Not surprisingly then, if you were to subtract a number from your function, it's going to shift it down. All the y values will decrease by 1. And that's what we call a vertical translation. Notice it doesn't change the shape of the graph, it just translates it or shifts it or slides it up and down depending on whether you add or subtract a number to the y value of the function. All right, let's talk about vertical reflections. Okay, so what would happen if I were to put a negative in front of my function? Well, that's going to make all the y values become negatives now, right? So for instance, what's this y value? That y value is 4. So if I were to change the sign, it would become -4. So that point would come down here now. How about this one? That y value is 3. What if I were to put a negative in front of that? That's going to shift it down here, directly below it, to the y value of -3. So on and so forth. If we keep doing that, we're going to end up with a graph that looks like this. And essentially what that ends up doing is flipping your graph upside down. So when you have a function and you put a negative in front of it, what it does is it makes the graph go upside down. And that's called a reflection. It reflects it across the x-axis. So the x-axis acts kind of like a mirror. Let's talk about stretches. So suppose I have my function here again. And this time I want to multiply my function. Move this out of the way really quick. Suppose that I wanted to multiply my function by a number. So for instance, let's just say I decided to multiply my function by 2. Okay, so let's say the a is 2. So I'm multiplying all my y values by 2. So if I multiply this y value by 2, I get 8. This y value is 3, so if I multiply that by 2, it becomes 6. If I multiply this y value by 2, I get 4. If I multiply this one by 2, I get 1. If I multiply this y value, which is 0, by 2, it stays the same. It doesn't change. And we could just kind of keep doing that all the way across. And as you can see, the result is going to be that the graph gets stretched vertically. Okay? Notice that the graph has the same width. It still goes from, let's see if I can. So I was saying that notice that it's the same width because it still goes from x equals -4 to x equals +4. So I didn't change the width of the graph, but notice that the graph did get taller. So that's a vertical stretch. Okay, all the x values stayed the same, but the y values got farther away from the x values because the x-axis because they all got doubled. Okay, so now that's what happens whenever you multiply the function by a number that is greater than 1. And notice I put absolute value bars on there. Because if I multiplied this by a 2, it's going to stretch it, right? Like we said. But what if I multiplied it by a -2? Well, the negative, it's 2, so it's all the y values are going to actually still get bigger in a way of speaking. But since it's negative, that's actually a reflection. So the negative doesn't affect the stretch. What the negative does is it just flips it upside down. It's the number itself, without the sign in front of it, that determines whether it's a stretch or not. So that's why we have the absolute value here. So if the absolute value of the number, meaning irregardless of the sign, is greater than 1, then that's going to stretch the function. Okay, but what about compressions? Well, if you take your function and you multiply it, but this time you multiply it by something that is less than 1, then it's going to compress it. Let me show you how that would work. So for instance, what's a number that's less than 1? Now, give me only a positive one, because once again, we only care about the absolute value. So give me a number whose absolute value is less than Well, some of you guys might say 0, but I don't want negatives, I don't want 0. So give me something between 0 and 1, like a half, for instance, right? So if I were to multiply my function by a half, that means I'm cutting all the y values in half. So this point here, the y value is 4, so if I cut that in half, it would go right here. This one is 3, so if I cut that in half, it's going to be 1 1/2. This one's 2, if I cut it in half, it's going to be 1. So on and so forth. So the result will be a vertical compression. And once again, I want to point out to you guys that the width of the graph does not change. It still goes from x equals -4 to x equals +4. The graph did not get skinnier or fatter. It just got smashed vertically. Okay, it got squished closer towards the x-axis. So that's what that does. So those are all of our transformations. And here's a summary of those transformations. So these are all verticals. So a translation up is what happens when you take your function and you add a number to it. A translation down is what happens whenever you take your function and you subtract a number from it. A reflection is what happens whenever you put a negative or multiply your function by a negative. And what that looks like is it flips your graph upside down across the x-axis. A vertical stretch happens whenever you multiply your function by a number whose absolute value is greater than 1. All the y values get multiplied by a. A vertical compression is what happens when you multiply by a number whose absolute value is less than 1, in which case it gets squished closer to the x-axis. So those are the 5 transformations that we've looked at so far. Now let's see what we're going to do with those in problems. So our objective for the day is basically I would like you guys to be able to look at these and tell me what happens. What does G represent? You know, is it what kind of a transformation has happened? You should be able to describe that to me. You should also be able to write a new equation for that transformation. So those are our goals there. So let's take a look at it. So we need to learn how to read and write and interpret transformations based on this notation. So here we go. Given that f of x is this function here, the absolute value of x. So we have a function and it's defined as the absolute value of x. Write an equation for g of x. So that's one thing that we're going to do is we're going to write an equation for g of x. And then we're going to describe what that transformation is. Okay? So this is each one of these questions is a 2-part question. We're going to write an equation and then we're going to describe it. Describe what sort of transformation it is. All right, so I'm going to start off with the first thing here, of course. I want to start by writing an equation for g of x. So let's start off by, I'm going to rewrite what they have here. G of x is equal to 2 times f of x. Okay? So what I'm going to do now is I'm going to replace f of x with what f of x equals. What does f of x equal? F of x equals the absolute value of x. There you go. So that's it. That's the end of part 1. I wrote my equation. All right? So the next thing is we want you to describe what the transformation is. So f of x is the absolute value of x. G of x is the same thing. It's just that it's been multiplied by 2. So when you take a function and you multiply it by a number that's greater than 1, what is that? Well, according to our chart on the other side, that would be a vertical stretch. And so what that means is that if you guys were to graph f of x, and then next to it you graphed g of x, which is 2 times f of x, or 2 times the absolute value of x, they're going to look the same. It's just that the g one will look stretched vertically. Okay? But there's our second part. We interpreted it. So Step 1, write an equation. So there's our answer to A. Step 2, describe the transformation. That's B. So there you go. Let's go ahead and take a look at number 2. Number 2, I like to start off like this just by rewriting the problem real quick. The next thing that we're going to do is to write the equation. All you do for this is you replace the f of x with what f of x equals. So I'm going to replace f of x with what f of x equals. And f of x equals the absolute value of x. So there you go. That's the answer to part A. So f of x is the absolute value of x, while g of x is negative absolute value of x plus 1. So now we want to describe the transformations. Now in this one, there are 2 transformations. We are doing 2 things to our f function. One of the things that we're doing to it is we're adding a number to it. The other thing that we're doing to it is we're multiplying it by a negative. And both of those are a transformation. So what happens to your function when you add a number to it? Well, that is a vertical translation upwards. It slides the graph upwards. What happens to your function whenever you put a negative in front of it? That is a vertical reflection. Okay, so since this one had 2 alterations to the f, we ended up with 2 transformations. So our answer to part A is negative x, absolute value of x plus 1. And part B, the result was a vertical translation up and a vertical reflection. So if you were to graph this function here, the absolute value of x, it would look something like this, just so you guys know. But if you were to graph the g function, what it would look like is it would look like the following. Change my color here. It would be flipped upside down and shifted up 1. So it's upside down, but it's also been shifted up 1 space. Okay? All right, let's go ahead and take a look at one more problem here before we set you guys loose on trying some of these. Number 3. First thing we're going to do is we're going to rewrite the problem. And if I want to write the equation, all that means is I'm going to replace the f of x here with what f of x equals. And f of x is equal to the absolute value of x, so that's where that goes. And there's my new equation. That's part A. Part B. So what kind of transformation is this? What happens to f if I multiply it by a half and subtract 3? Well, it looks like there's 2 transformations again, right? We have a minus 3, so we're subtracting 3 from it. And we also have a multiplication by a half. Well, whenever you multiply by a number that is less than 1, or whose absolute value is less than 1, I should say, because we don't care about the sign. Remember, if this is ever negative, the negative means there's a reflection. So we don't take that into account when we look at the number itself. The number is, the absolute value of that number is less than 1, therefore that's a compression. That's a vertical compression. But what about that minus 3? What does that do? Well, that's a vertical translation downwards. So once again, the graph of f looks like a V. It looks like this. But the graph of G will look like a V also. It'll look the same as f. It's just that it will look shorter because it got vertically compressed, and it will be shifted downwards. So it might look something like this. Notice it looks a little bit more stout because it got squished vertically, and it's also been shifted downwards. Now I'm not being very precise with my graphs because I'm not going to get actual numbers on here, but we could. You could actually graph this, plug in some numbers for X, get some numbers for Y, put a bunch of dots and connect them. And then what you could do is you could take each one of the Y values, multiply them by a half and subtract 3, and rewrite and redraw the new graph and get a very specific graph. You don't need to do that at all. Matter of fact, you just don't have to graph at all. I'm just doing that to help your concept develop here. All you need to do is what we have here, write the equation and interpret what that equation does. What transformation is it? So that's it for now. I'm going to have you guys go ahead and do these 3 problems here. Pause the video, and when you're done, you will see the solution. Okay, so for number 1, this is what your equation would look like. You just replace the f of x with the absolute value of x, and you've got your equation. So that's g of x now. And since we're multiplying by a number less than 1, that's a vertical compression. And since we're adding a number, that's a vertical translation up. For number 2, here's my equation. Now, believe it or not, number 2 has 2 transformations on it. Since it's negative, that's a reflection, a vertical reflection. And since the number after the negative is greater than 1, it's a stretch. So it's a vertical reflection and a vertical stretch. Number 3, this one's weird. It's a fraction, right? But it's still, that number, 3 over 2, that's bigger than 1. So we're multiplying by something greater than 1. Therefore, that's a vertical stretch. And we're subtracting by 3, so that's a vertical translation down. All right. So that's vertical transformations. Now we're going to talk about horizontals. Now I'm going to backtrack a little bit. A little bit earlier, we said that with transformations, when you apply transformations to the y values, it results in vertical transformations. Now, another way of saying y, as we've said earlier today, is f of x. So anytime you do something to the f of x, you get a vertical transformation. But whenever you do something to the x value, you get a horizontal transformation. So what that looks like is, instead of doing something to the f of x, what we do is we do something inside the parentheses to the x itself. And that results in horizontal transformations. It causes the graph to either slide, flip, squish, or stretch horizontally. So let's take a look at that. All right, so suppose I have my function here once again, f of x. And now let's say that I were, can't see everything on this slide. That's not good. Just a second. Okay, so I'm going to start over with this one. Couldn't see it all. So here's my function f of x. Now, suppose I subtracted a number from the x value. What that's going to do is it's going to translate my graph to the right. Okay? Now, the reasoning for that is a little bit complicated, so I'm not going to go into why it does that at the moment. But I just want you guys to know that whenever you subtract a number from the x inside the parentheses, it causes the graph to shift over to the right. Every point goes over that far. Okay, so on this picture here, what I've done is you could think of this as being let me write it in there, a 4. The h would be a 4 because what I've done is I've subtracted 4 from every x value. So for instance, this is 0, but this x value is 4. It went over 4 spaces to the right because I subtracted 4. Now that's weird. You would think, well, wait a minute, Mr. Bailey, if you subtracted 4, then wouldn't that be negative 4? So wouldn't it go over here? And the answer is no. It's weird, but just bear with me for now. The fact of the matter is that when you subtract a number, whatever that number is, that's how far every x value goes over. So this vertex slid over here. This point went there. This point went there. This point went there, and so on. So the whole thing got slid over to the right 4 spaces because I subtracted a number from the x. In the same way, if you add a number, it will move every point that far to the left. Okay, so those are horizontal transformations. So here's what they have in common with verticals. With verticals, it's the same thing. If you add or subtract a number outside the parentheses, it slides it up and down, right? Well, if you add or subtract a number inside the parentheses, it slides it left and right. But keep in mind, with x's, for some reason, it does the opposite of what you would think it would do. So subtracting actually moves it to the right, whereas adding actually moves it to the left. That sort of weirdness doesn't happen with verticals, but it does with the horizontals. All right, let's take a look at another one. Another horizontal transformation. What else can we do to the x? Instead of adding or subtracting a number, we can also just make we can multiply the x by something, okay? So for instance, if I were to multiply my x by a number whose absolute value is less than 1, so once again, like a fraction or something, it's going to make it wider. Okay, it's going to stretch it horizontally. That's if you multiply it by something less than 1. So for instance, if you multiplied it by a half, and once again, you might be thinking, well, wait a minute, Mr. Bailey, if we're multiplying the x by a half, isn't that going to make all the x values smaller? So for instance, this point, what's the x value for this point? It's 4. But it gets moved over here now, and that's 8. Why did the x value get bigger? It went from 4 to 8. Why did it get stretched if I'm multiplying it by a half? Well, once again, x's are weird. They do the opposite of what you would think. And I'm not going into why. Once again, I'm just telling you that's the fact. So when you multiply x by a number whose absolute value is less than 1, it stretches it horizontally. Okay? So what do you think is going to happen then if we multiply it by a number whose absolute value is greater than 1? It's going to compress it. Every number will get closer to the y-axis. So, and I want to point something out to you guys. It got compressed, right? Horizontally. So this point here got squished closer to the y-axis, and so did this one. The whole graph got squished towards the y-axis. It didn't change its height though, right? They both have the same height. They both go from 0 to 4 in their height because the y values aren't changing. It's the x values that are changing. So there's that. So if you multiply by a number that is less than 1, it stretches the graph horizontally. It doesn't change the height, but it does stretch it horizontally. If you multiply by a number greater than 1, it compresses it horizontally closer towards the y-axis. So there it is, there's that. And our last one, reflections. So for this one, I had to pick a different graph. I'll let you think about why that is, but it's not important. If this is my graph here, f of x, and let's say that I multiply the x by a negative, what that's going to do, this one makes a lot more sense actually. What it's going to do is it's going to make all the x's change their signs. So what's the x value here? Well, that's 1. So now that point is going to become negative 1. The x is now negative 1. What's the x value here? It's 2. So now that becomes negative 2. This one, what's the x value? It's 5. So now that x value becomes negative 5, and so on. And so that one is pretty straightforward and simple. You just reflect it. It reflects it across the y-axis. So same transformations, but just done inside the parentheses, which means that it's affecting the x value instead of the y value, which means that these are all horizontal transformations. And here's a summary of everything that we are just finished talking about. So we have here the summary for horizontal transformations, and what I want you guys to notice is that all the changes now are inside the parentheses, right? So that's what causes horizontal transformations. So when you're adding or subtracting inside the parentheses, that results in a translation to the left or right, depending on whether it's minus or plus. If you make your x a negative, that is a horizontal reflection, which flips it across the y-axis. If you multiply it, you get either a stretch or a compression, depending on whether the absolute value of your multiplier is greater than or less than 1. Okay? And so that's horizontal transformation. So let's go ahead and take a look at the questions that I'll be asking you guys to do for these types of problems. Pretty similar, slightly different. Let's go ahead and take a look. So, number one, we want to write an equation and describe what the transformation is, right? So here is my expression. Okay, so whenever you have something inside the parentheses, what you're going to do is you're going to take what f of x equals. You're going to put it there and you're going to put some parentheses where the x was. So f of x is the absolute value of x, right? But now instead of x, I'm going to put parentheses there. And what goes in the parentheses is what's in the parentheses up here. Now, technically, you don't really need the parentheses on this one, but in many problems, you will need parentheses. And so I would encourage you just to kind of get used to doing it. But the goal is, it's kind of like last time. So I just want to go through it one more time, okay? So I start by writing the problem. Then I replace the f of x with what f of x equals. That's the absolute value of x. But instead of x, since I have stuff in the parentheses, I replace the x with parentheses. And what goes in the parentheses is what's in the parentheses up here. Okay, so my final equation here would be that. That's the answer to part A. That's the equation. Now I need to describe what that transformation is. Well, I'm subtracting a number from the x. And when that happens, that results in a horizontal, I'll just use H, translation to the right. So it would slide my graph to the right. So f of x, the absolute value of x, looks something like this. But since I'm subtracting 3 from the x, the whole graph would shift like 3 spaces to the right. Should be touching the x-axis still. Okay? Once again, you don't need to draw the graph. You can just do the A and B part. All right, next one, number 2. So once again, we're going to start by rewriting the original problem. And then we replace f of x, or f of the f expression there, with what f of x equals. But when we do, where the x is, we're going to put parentheses. And in the parentheses goes what's in the parentheses to begin with. And there's that. Now this is a fine answer. We can leave it like that. But I'll show you something we can do with it in a minute. But for now, I want to draw you guys' attention to this. There are actually 2 transformations here. There is a negative, and we're multiplying it. Since it's negative inside the parentheses, then that's going to be a horizontal reflection across the y-axis, okay? The 2 would be a horizontal compression because it's a multiplier. And when you multiply the x by a number that is bigger than 1, you get a horizontal compression. So once again, I'll draw a picture, something you don't have to do, but just to kind of help you understand the idea. F of x looks like a regular V shape, but it's being reflected horizontally. Now that's funny because if you take that V shape and you reflect it horizontally, it looks exactly the same because it's symmetrical around the y-axis. So if you flipped this thing horizontally, it still looks the same. It doesn't change it. So in this case, a negative doesn't alter the way that it looks. But we can definitely compress it. We have a horizontal compression. So that means it's going to have the same height, but it's just going to be a little bit skinnier. So ultimately, it's going to look like that. Okay? Go ahead and take a look at number 3. Now, 3 is a special situation. Let's go ahead and do part A, though. Part A is pretty straightforward. Nothing special there. So for part A, we just want to write the equation. What we do is we rewrite the problem first, just because Mr. Bailey has OCD. And then after that, we write it again, but in the place of the f of x, we put what f of x equals. And where the x is in the f of x expression, we're going to put parentheses so that I can take what's in parentheses up here and put it in down here. And there you have it. Okay? Now, that's for part A, and we're done. But something funny happens here. All right? And I'm going to encourage you guys to write this little note. If you have If you guys hear my TV in the background, I apologize. I'm working from home right now, and my son has a TV on, so I'm going to turn it down. I don't know if you can hear it or not. Anyway, if you have something like this, where it has both an A and a B, all right, well, before we can interpret it, we need to factor out the A. So I'm going to write that down as well. And I'll put in parentheses here, see example 3. Okay? So before we interpret what the transformations are, we need to factor out the A because it will help us actually interpret it correctly. All right? So if you have f of a x plus b, we have to take the a out. So anytime you have both the a and the b in there, that's what you'll need to do. Okay? So let's go ahead and do that then. Just a second. Show you what I mean here. What do I mean factor out the a? The a is the number that's multiplying the x. We need to take that -6 out of these two things. So let's divide both of these by -6, okay? So what's -6 divided by -6? That would be 1. So now it's 1x. So we'll just write x. And what's 12 divided by -6? It's -2. Now you might think that's lame, but this is what helps us to interpret it properly. By doing this, this is the number that tells us what we're multiplying by, whereas this is the number that we are shifting it by or translating it by. Okay, so up here, if you just looked at it, you might have thought, oh, well, we're translating at 12 units. Well, no, we're not actually. That's a 12 because the 6 is affecting it. And so by factoring it out, we've separated the transformations from each other so we can see them separately. Okay. So really what we're doing is we have a multiplier of 6, a subtraction of 2, and then there's a little negative there. So there's actually 3 transformations here. Okay, so let's go ahead and interpret all of them. All right, so first of all, the negative is a horizontal reflection. Next, since I'm multiplying by a number bigger than 1, 6, that is a horizontal compression. And then finally, since I'm subtracting 2, that's a horizontal translation to the right. Okay? There's a lot going on there. So I want to remind you guys of this little note up here. If you ever have in the parentheses an a number multiplying the x, and a b, a number being either added or subtracted, it doesn't matter if it's positive or negative, you have to factor the a out. Divide the number in front of the x out of both terms with the parentheses there. Now, and that way you will accurately see the transformations. Okay? So, before I go on to number 4 then, 4 and 5, I want to pause there and let you guys do some problems like those because I don't want to overwhelm you with too much stuff. So, here's what I want you guys to do. I want you to stop here and pause the video, and I want you guys to do numbers 1 through 3. Okay? Do numbers 1 through 3. All right. So here's the equation for number 1. And that is a horizontal translation to the left because you're adding a number. Here's the equation for number 2. Now there's 2 transformations there. Okay? First of all, we have a negative. So that's a horizontal reflection. Next, it's being multiplied by 5/7. Now 5/7 is less than 1, so that would be a horizontal stretch. So we have a horizontal stretch and a reflection. Number 3, here's your equation, but don't forget when you have an a and a b, which we do, you need to factor the a out. So in this case, we're going to divide 3 out of both of these terms, and I'm left with 3 parentheses x minus 2 parentheses. Okay, and that means that this 2 right here is your horizontal transformation to the right, and the 3 is your horizontal compression because it's bigger than 1. All right? So we're not moving this graph 6 spaces to the right. We're moving it 2 spaces to the right, and we're compressing it. Okay? So that's the difference there. Let's go ahead and take a look at some other problems here now. All right, so numbers 4 and 5 are just kind of taking it to the next level. Let's go ahead and before we do number 4, I want to review a basic math idea with you guys really quick. What is 8 divided by 4/3? You guys remember how to do that? Well, 8 divided by 4/3 can be calculated by doing 8 times 3/4. Something you might have heard teachers say in the past is same change flip, okay? Or keep change flip. After you do that, you can multiply straight across and you get 24/4, which is 6. So that's how you divide numbers by fractions, right? So if you guys feel like you need to practice that, I'll give you one really quick because you're going to need to know that fact in just a moment. So suppose I said we had 10 and I said divided by 2/3. What would you get? First, you would do same change flip. You would multiply straight across. Oops, that says 30. And then you would reduce. The answer is 15. Okay, so you're going to need to remember how to divide fractions in order to do part 4. So number 4, we start off like this. So we rewrite the problem. And then we replace the f of x with what f of x equals, which is the absolute value of x. But since there's stuff inside the parentheses this time, we're going to replace the x and the f of x with parentheses, and we're going to drop that stuff down inside there. Nothing new so far, right? And that's the end of part A. We're good. Let's go on to part B, though. Before we can interpret it, we need to do something. We have an ax plus b, right? We have the a and the b. So we need to divide that half out. So I need to take a half out of the parentheses. I need to divide that out. So if I divide a half by a half, only time you divide something by itself, you get 1 x there. But now I need to divide 3 by a half. How do you do that? Well, 3 divided by a half can be calculated using the process I just shared with you. So same change flip. So 3 over 1 times 2 over 1 is 6. So what actually ends up going here is 6. Okay? So whenever you have a fraction, it's a little tricky to divide out that front number, but that's how you do it. But anyway, the half tells me that we have a horizontal stretch because I'm multiplying by a number that is less than 1. Next, we have the 6 there being added to the x. So that tells me we have a horizontal translation to the left. Okay? So let's have you guys try one of those really quick before we do the last one. Go ahead and do number 4. Now, for number 4, there's not a number in front of the x that you can see, but there is a number there. If there's a negative, you can imagine there being a negative. You know, I don't really like, though, how there's no fraction there. I really wanted you guys to practice a fraction. So, you know what I think I'm going to do is I'm going to change the problem. I'm going to change the problem. I want you guys to be able to practice the fraction. Let me make one up for you real quick here. So I'm going to erase that. And then in the parentheses, I'm going to put negative, let's say 2 thirds x plus 2. Negative 2 thirds x. All right, so go ahead and try that one really quick. Pause the video, and when you unpause it, you'll see the solution. Okay, so the equation, as you see here in part A, is the absolute value of negative 2 thirds x plus 2. In part B, to interpret it, we need to factor out the 2 thirds so we can see the horizontal transformation correctly. The negative that we have there gives us a horizontal reflection. The 2 thirds is less than 1, so that's a horizontal stretch. And then we're subtracting 3, which is horizontal translation to the right. And if you want to know how the 2 became a 3 when we factored out the 2 thirds, I've got my work up here. We did 2 divided by negative 2 thirds, which is 2 times negative 3 halves. Multiplying straight across, you get negative 6 over 2, negative 3. Okay, so there's that. Let's go ahead and do one more problem for the day. And the special thing about number 5 is that we're just combining vertical transformations with horizontal ones. Here's how you can see it. You see how I have some numbers outside the parentheses? Those are things that are affecting the f value, in other words, the y. So those are vertical transformations because they're outside the parentheses. But this one here inside the parentheses is a horizontal transformation. So yes, you can have both horizontal and vertical transformations simultaneously. Okay. So the first thing that we're going to do is we're going to rewrite the problem. And in the place of the f, we're going to put what the f equals, the absolute value of x. But since we do have something in the parentheses here, instead of absolute value of x, we're going to put absolute value of parentheses. And what's going to go in the parentheses is the x minus 5. And so we have our f of x minus 5 right here. And then we have our multiplication by 2 here and our plus 3 here. So our final equation is, as you see there, x minus 5 here, and we're good. So there's your part A answer. Now for part B, we've got to interpret this stuff. We have a 2 multiplying the outside of my function. We have, I guess we could use, yeah, this is fine. We have a 2 multiplying the outside of the function. We have a 5 being subtracted from the x on the inside of the parentheses. And then we have a 3 being added outside of the parentheses. Both the 2 and the 3 that you see there, those are going to be vertical changes because they're outside the parentheses. So when you multiply by a number that is bigger than 1, outside the parentheses, that is a vertical stretch. Whenever you add a number outside the parentheses, that is a vertical translation upwards. And then finally, when you subtract the number inside the parentheses, that would be a horizontal, because it's inside the parentheses, horizontal translation to the right. So just to give you a picture to visualize what's happening here, if this is what f of x looks like, the absolute value of x, then with this particular transformation, it's being stretched vertically, and it's being shifted to the right and up. So if I took this V shape here, I wonder if I can move it. I'm going to try something nifty here, just a second. Maybe creative with my technology. So here's the graph of f, right? So according to this, it's going to be shifted to the right. It just moves the whole thing. I was hoping it would just move the V shape, but it won't. Tried to be creative. I'll just do it old school style. So it's going to be shifted to the right and up, and it's going to get stretched vertically. So it looks skinnier because it's getting stretched, but I moved it to the right, went over and up because of these transformations here, translations, and then it got stretched, so it looks skinnier now because it got stretched upwards. And it went off the screen, so we can't see the rest of it. Anyway, there it is. All right, so let's have you guys do one where you are going to combine both vertical and horizontal transformations. So go ahead and do number 5 down here on the student practice, and pause the video, and when you unpause it, you will see the solution. Okay, so here it is. Here's what the equation would look like. The negative here outside the parentheses results in a vertical reflection. The 2/3 outside the parentheses is a vertical compression. So vertical compression. The 4 inside the parentheses is multiplying the x, and it's greater than 1, so that would be a horizontal compression. And then the -3 outside the parentheses is another vertical thing. It's a translation downwards vertically. Okay, and so that's it for our transformation chats today, and we'll see you guys next time.